And our last distance before I go into the tutorial is the L-infinity distance. So again, it works with categorical data only. It is in some ways similar to Euclidean distance if you just increase the number of dimensions quite a lot, and it works in the range 0 to 1. It is quite a specialized measure. And what it captures, as you can see here, is basically the maximum difference between the relative frequencies. So we have relative frequency displayed here for our categories A, B, and C. And it basically just looks at the one that has the highest difference in relative frequencies, which means it's very nice and very good to use in features with many categories. Almost all other statistics actually will slightly increase as you add more categories, because there's always going to be slight changes in the category distributions, and they don't fully take into account, basically they don't normalize for the number of categories, or they don't control for the number of categories fully. It's just something that we saw in our internal experiments. However, L-infinity distance does, and it is very robust to noise in features with many categories. So if you have a feature that has, let's say, 100 or 1,000 different potential categories, you might want to use L-infinity distance. And of course, there is a drawback to that, which is it's sensitive to changes in just one category, basically because it's defined as a maximum difference, so it's going to look only at one category, which means that it's potentially also sensitive to changes in categories that just can appear and disappear. Then your infinity distance is going to be basically 1 because the relative frequency is 0 at some point. So if you have a categories that really change strongly, they go from being present and strongly present, let's say 50%, and then disappearing next time. It's every single measure would show drift, but that one will be quite more sensitive to that. So that is the last one. And here we can see why you shouldn't use it. So I already told you why you should use it. Now looking at why you shouldn't use it, we have the same drop of location feature that we had previously. And we always said that there's actually some kind of drift. But here, because there is not one single strong change, but a lot of changes in many different categories, L-infinity actually fails to capture that. And here we have actually a rare case for univariate detection methods of a false negative when there is actually a drift, but we cannot capture it with the L-infinity distance.